Hi, everyone. Thank you for coming to our webinar series for the MSc Engineering and Education Colloquium. This is the first time we are running this series of webinars. Our main objective basically is to connect the MSc to students, to alumni, to researchers within UCL, the UK, and all over the world. It's an engineering education platform, and we are basically using it to discuss what our students, our alumni are doing out there in the world. Today we have got Dr. Chika Nweke. She is from the Biochemical Engineering Department here at University College London. She is one of the module leads of one of the core modules on our engineering programs, undergraduate engineering programs. She is the lead for the IEP design and professional skills. She also runs a number of courses at master's level in biochemical engineering within her department. And she is a recent graduate of the MSc Engineering and Education. She is interested in inclusive education, pedagogic education, gender issues. And today she is here with us to discuss the work she is carrying out here at UCL on pedagogic innovation, on inclusivity, on gender issues from gender equality within engineering education. The title of her talk is Pedagogic Innovation on the IEP to Support Inclusive, Future-Proof Engineering Education. Dr. Chika, I hand over to you.
Thank you, Abel, for such a comprehensive introduction. Afternoon, everyone, or morning or evening from wherever you're joining us. As Abel said, my name is Chika, and I'm here to talk to you today about the work generally that's going on particularly on the IEP to support inclusive, future-proof engineering education. So there's not too much focus on a particular area of inclusion. It's kind of all-encompassing. But I will talk a bit more specifically about the work that we're doing, particularly on one of the IEP modules called the challenges, to promote inclusion, to ensure that it's as future-proof and flexible as possible. So we all know how COVID-19 has impacted the way we educators teach and the way students learn. There are some strategies that were adopted that I call firefighting strategies, and some temporary fixes. But from that, we've been able to really take on strategies that are hopefully here to stay, because we've seen how much further they can take the education that we're looking to give. So I will, the screen doesn't want to move, there we go. So today I'd just like to walk you through how we got to where we are. So I'll be using, as I said, the integrated engineering program as a main basis. And for those of you that aren't familiar with it, I will touch on a bit on how the program works and what it entails. And then the lasting changes in the continued effort to support an inclusive and future-proof engineering education. So I will touch, as I said, on the challenges module. What we were doing pre-COVID, perhaps we weren't to know what was going to come and the challenges that we experienced because of COVID, but how that led to innovations in practice, including innovations to inclusivity, and where we're looking to go in general. So beyond the challenges and perhaps beyond even undergraduate teaching. So for those of you that don't know too much about the integrated engineering program, though I know that there are loads here that do, so I'll try to make it as quick as possible. But it is a great program that was put in place ultimately to kind of fill in the gaps that industry, accreditation bodies, governments, various stakeholders had noticed about our engineering graduates coming out of university. So we all know the importance of technical competency. We know what the ability to code has done for the digital age. We know what the technical skills in bioprocess manufacturing has done in the response to COVID and other outbreaks. But industry and stakeholders realize that these technical skills are somewhat futile if our engineers do not know and understand how to apply it in a worldly manner and how to ultimately engage with societal needs. So through that, the Integrated Engineering Program, or the IEP, as I'll refer to it going forward, was born. And of the, I think it's 10 or 11 departments that we have in the engineering faculty, 8 departments, so a large majority of the faculty are on the Integrated Engineering Program. So you can see from this image here of the UCL IEP structure that departments like the one I'm based in, biochemical engineering, biomedical engineering, chemical, etc., all take modules that are IEP modules or IEP framework modules. So the engineering challenges, design and professional skills, mathematical modeling and analysis are taken in the first year across these departments that you can see. And then there are further IEP modules taken throughout the undergraduate degree up until the students graduate. So through those modules, as well as the framework from the IEP embedded into the departmental modules, students are able to really gain those professional skills that the industry really needs for our engineers to be able to come up with real, lasting, sustainable, safe solutions. So the IEP came about in terms of implementation in 2014. And in recognition of what it has done for undergraduate programs in engineering, it received the CATE Award in 2017, which was a great achievement and a show of real leadership and educational innovation. So that's a little bit about the IEP for those that don't know. So as I said, what I was going to focus on was the challenges module. So that's the module that we saw in the previous slide in blue that students take in their first year, right from the first term. So the reason why I'm focusing more on this is because this obviously Abel described my role in the IEP with connection to design and professional skills, which I will also touch on. But this module in particular is one that I'm quite hands-on with in terms of being in the classroom and really influencing change on that level. So I'll talk a bit about what we did pre-COVID and then the challenges that came about as a result of COVID and what has been kind of lasting in those in the sight of the pandemic. So traditionally what we did was we had what was called the Challenge 1 and Challenge 2. Each were 5 weeks long. Students worked in groups, so this was wholly a team-based module. So students worked in groups right from the start in Challenge 1, but the main difference between Challenge 1 and Challenge 2 was that students worked in their departments in Challenge 1. So amongst themselves, for example, biochemical engineering students worked with biochemical engineering students to solve what was mainly, to come up with what was mainly biochemical engineering solutions to a very niche area. So an example might be how to use biofuels to solve issues to do with energy in a specific remote part of the world. So biochemical engineers would work in groups to solve that particular issue. And obviously the same applied for other departments as well. Now, my main focus though will be on Challenge 2, because that was where we saw the most pedagogic innovation in our practice and application. So on this particular challenge, students worked again in groups, but they worked in interdisciplinary groups. So what that means is they worked with other disciplines to solve a global health issue. So in my particular cohort, biochemical engineering students worked with chemical and biomedical engineering students. Electrical and electronic engineering students worked with computer science students, and mechanical engineers worked with civil engineers, all to solve kind of an umbrella problem, if you like, the manufacturing of a vaccine to cure tuberculosis in Uganda. So the good thing about this project is that not only that students were able to work with other disciplines, but they all came back together to discuss important aspects that kind of threaded through all of the disciplines related to sustainability, ethics, cultural awareness, risk. So biochemical engineering students were able to work with chemical engineers, biomedical engineers, but still work with electrical, computer science, mechanical, civil. So that was what we were doing pre-COVID. But as we know, COVID kind of hit us like a ton of bricks in March of 2020. And as a result, we had to change a number of things that we were doing. So at the time, fortunately, we were towards the end of term, and the immediate kind of focus of planning was around exams. But then after that came the issue of having a limited period of time to plan for how we would move forward under remote conditions. So another consequence of COVID was that we had a significant number of student intake. I think there was a rise of more than 30% across the faculty on the IEP, on different IEP modules. So that in itself would have presented problems even if we were face-to-face, but combined with remote working, there were many areas that it impacted. So I'm going to focus on three main areas that it impacted for the challenges module and how we overcame those. The first thing, what to do about labs. So in those groups I mentioned earlier, students go into labs to run experiments to come up with, to help them in their solution to that global issue. And engineering as a whole is a very hands-on area. So what do we do about labs in this, in the face of the coronavirus pandemic? What do we do about teamwork? How do we move forward with students working in teams where they can't see each other and those social nuances are lost? What do we do about that? And what do we do about supporting our students staff support of our students in this setting. So those were the three main areas that came up that we had to come up with an answer to. So for those of you that may not recognize this image, I hope some of you do, but when we were thinking about lab innovation, we went through a number of options, but I think the source of inspiration from this was from a colleague of mine's children who play Minecraft, as this is what the image shows. And it was from that we kind of came up with the idea of using a tool like Minecraft to try to simulate the conditions that students would work in labs. So the great thing about using Minecraft was that we were able to really put in realistic conditions of how the students would be working, for all the way from students needing to wear lab coats in labs through to students being able to input their conditions into a bioreactor to conjure up their results. Now, as good as this tool was, we did experience obvious limitations, but I believe those limitations were largely to do with the amount of time that we had to put it together. But in saying that, what this has done is this has allowed us to realize the importance of students being able to use technology before going back into labs. So in this year, where we had a more blended approach of learning because students were able to come back onto campus, the innovative thing that we took from being solely online was that the importance of being able to use computational methods to predict your experimental results. So going forward, I believe that it's something that we will continue to consider, perhaps using other platforms such as ANSYS or Labster. Now, looking at inclusivity, there were a number of things that we had to implement and had to think about to make sure that we didn't lose the engagement of our students in this process. Obviously, working remotely is something that was probably new to students at the time, as well as being thrown into interdisciplinary teams. So what was put in place was students being able to lead in their engagement of the project. Students being able to manage their time effectively, students being able to notify staff at different levels in order to ensure the engagement of their teammates. So a system was put in place by the faculty lead for this module where students were able to be on Microsoft Teams that allowed them to speak to each other at different times of the day, and then also report to, first of all, the departmental leads using a systematic process, and then failing any attempt to get the fellow teammates to engage, it went up to the faculty lead. We found that this process, although it had some limitations, it really did allow the students to take the lead on their own engagement and what they were responsible for, and made it easier for them to self-certify where they were having issues with engagement and being involved in student activities. Something else that we were aware of, and because of the limitations on brought about by the pandemic, we were more aware of the cultural influence on ways of working. So with students being in different parts of the world, what would make it easier for them to work together and understand each other better in order to move forward? So there are many studies that detail the importance of perhaps cultural similarities, and team cohesion. So being able to set teams up according to time zones was something that worked well in the when we were working completely remotely, and allowed students to freely communicate or communicate much better. Now, we're aware that a limitation to that is that we maybe somewhat take away from um, one of the main things of team working, which is the diversity in the teams. So a good thing about being this blended approach that we have at the moment, where where students are partially back on campus, is that we still maintain the online presence of pre-recorded lectures for students to be able to learn at their own pace and learn in a way that suits them. But we also have the face-to-face element where students are able to meet in a diverse teams and integrate in that type of way as well. So this blended approach does promote both what we learned over COVID and our pre-COVID practices, and allows for kind of the perfect blend of both of them. So as I mentioned, a lot of when we were completely remote, a lot of the communication, or all of the communication, was via Zoom or Microsoft Teams, mainly Microsoft Teams, and we're able to maintain those platforms for ease of communication for students looking to directly contact the tutors or the departmental leads, and as well as each other, but also able to meet up in face-to-face settings and have that flexibility in communication for the students. And in terms of pedagogic support, so the things that had to be implemented as a result of the pandemic was a shift in time span for Challenge 1 and Challenge 2, because Challenge 2 was an interdisciplinary part of the module and really met a lot of the learning outcomes. But in so doing, students were able to have more of, they were able to really communicate much better and engage better with the content that we had made for them online. It gave us the time to make sure that students were up to speed with the changes that had been put in place. And it was really something that we received positive feedback on, and we're looking to keep going forward. Also with pedagogic support and support from the faculty to have more staff available, so what we call PGTAs, postgraduate teaching assistants, to really give that increased support in uncertain times. And that is something that has continued through, even going partially back to face-to-face. And increased staff availability was something that we would be looking to continue going forward. Staff being available online at different hours of the day to cater to different student needs. And as I mentioned earlier, the pre-recorded tutorials for students to be able to learn at their own pace, being released in a timely manner, and allowing for students who have questions or queries to resolve that before face-to-face sessions. So a lot of pedagogic support that was put in place during the pandemic or in response to the pandemic is something that continues going forward, that we're keeping on this module. So in terms of looking forward, as I mentioned, this is just a summary. I think one thing or a couple of things that haven't been mentioned yet are certain technologies that have proven to be really quite effective and really what I would call COVID resilient. So students do a lot of presentations on across the IEP and in their degree in general. And a really good tool that has been used this academic year is called Go React for presentations. So the use of Go React, particularly on the design and professional skills module, allows students to peer assess each other on one platform, and it is easily integrated into Moodle as well. So they can also use the platform to practice their presentations, as well as to share their presentations with students or their peers, and also with marking staff. So it's kind of like a big, it almost simulates real face-to-face presentation styles. So that has proven to be a really good piece of technology that we will look to keep going forward. And another thing is flexibility with assessments. I think COVID really taught us, as well as the increase in student numbers, to be quite flexible with how we assess students. So having the option to, for example, if it is presentations, do face-to-face presentations or online presentations on the challenges module is something that has been presented, and also with other modules going forward. So it's important to maintain that in future planning for different engineering modules going forward. So if we're looking to the future and developing more inclusive practices, the Engineering Council, who kind of oversee accreditation for different engineering disciplines, have kind of put a statement out to say, or to rather give information on what needs to be included to promote inclusive practices in engineering disciplines. So that's looking at not just undergraduate education, but also looking at a research as well. So something that's in the discussion phases at the moment in different parts of the engineering faculty is looking at responsible innovation in research, which is something that I hope to be more involved in. So looking at or getting our researchers, our PhD students, or undergraduate students involved in research to really think about how their research is inclusive, to really think about the sustainability, the impact of ethics on their research, and to include that in their outputs. So that's something to watch out for. Another thing currently in the ideation stage is looking at student-led contextualized education practices. So we know that as educators, we can provide the technical expertise or that technical foundation that students might need to move forward in their education. But what if the context in which it was applied was student-led? A lot of the time what we do is we set the scenario or we set the context, and the students would look to see how they would design it. But if students were able to contextualize that themselves, like an idea that that I've discussed recently with a colleague, there may be, for example, students that are lactose intolerant, for example. If they were able to take that and apply it to their education, pick a scenario in which they can solve an issue that they believe is pertinent and will also cater to many people in the world, why not give them that opportunity? That will allow students to really feel like they are more in control of their education and are able to really directly see the impact of their work in society. So those are some of the things that we're looking to establish in the faculty and hopefully beyond the faculty, and more to come as well. So this is a really growing area that we're interested in pursuing. Right, and with that said, I have just a reference here that I used earlier on in the slide. I really give full acknowledgement to my colleagues that have helped us to get this far and will continue to be drivers in the area of inclusion in engineering, and also in ensuring that we have future-proof, flexible ways of working as well. So thank you to all those involved, and thank you to those here, and I'm happy to take questions.
Thank you, Chika, for the excellent presentation. For our audience participants, if you have a question, you can raise your hand, or you can type in the Q&A or the chat, and I'll take it from there. If you want to speak, I'll give you permission to actually have a conversation with our presenter, or you can just post it in the chat and I'll do the speaking for you, whichever you are comfortable with. Chika, I would like to take you back to the COVID crisis, because what I'm hearing from across the sector is the COVID pandemic set back a lot of students, such that they don't quite meet the academic accomplishments they were supposed to have accomplished if COVID was not there. What are your experiences at UCL, or in particular depths within the biochemical engineering department?
Yeah, so I mean, there have been studies as well that I've seen and have been involved in personally that that show that some students, or rather certain groups of students, felt like they maybe missed out on a lot of the learning that could have been done if it was face-to-face as a result of the pandemic. And what I would say to that is that industry and the working professional world is also aware of these problems. And we are actively working with industry to ensure that these flexible platforms and these flexible ways of working can still be representative of industry ways of working. Yeah, one thing that I know of is that in biochemical engineering, when we work closely with companies, we're able to, for example, communicate the needs of what those companies are and how those companies can educate themselves to set up the necessary training for the students coming out of the previous year that may not have been able, for example, to go into labs and gain those lab skills. So that's something that we're involved in. And also those students that continue throughout the program, we're able to set up more ways that students can gain the skills that they perhaps weren't able to pick up in previous years, and kind of change around the timetables to help students really pick those up. There's also more support as well from the faculty in terms of financial aid for students to be able to come up with projects and to be trained in labs as well. So a lot of initiatives that have come out of the COVID impact to help students really regain those skills that were perhaps lost in the pandemic.
Then another issue which I might perhaps want to hear a little bit from you is there is a suggestion that the pandemic brought about quite some significant inequality between those who can afford to have the gadgets and those who cannot quite afford to have like state-of-the-art laptops, better connectivity. How did you see that problem within the UCL engineering student body, and how did you tackle it?
Yeah, so I mean, I would go as far as saying myself as an educator, I didn't always perhaps have access to because of my living conditions at the time, didn't always have access to stable internet connection. And so I experienced a lot of the issues that students experience and was able to empathize with that. And that's why I think it was important to increase staff accessibility and increase staff support during those times in particular. It meant that our working day was longer, but it was necessary in order to meet students halfway, if you like. So I know that that was an immediate firefighting response at the time. I think that the benefits of now, hopefully things slowly going back to normal and us having this blended approach, is that a lot of our online material can remain. And also we can support students in a face-to-face capacity as well. So I think I also appreciated more the benefits of having pre-recorded material for students to be able to learn at their own pace. So again, as I said, that's something that remains and something that is future-proof as well, that we will continue to have going forward.
Ladies and gentlemen, just feel free to ask any burning questions you might be having. We've got a question from Bailey. Bailey, let me enable you so that you can talk, allowed to talk. I think your mic is now free, Bailey.
Yeah. Hi, Abel.
Hi.
Thank you so much for your sharing. And I've noticed that you mentioned lab innovation in your speech, and I'm wondering if you could specify the lab innovation.
Yeah, so with the lab innovation and the implementation of Minecraft as a tool for lab simulation isn't something that we'd done before, and isn't something that we'd seen being done in the way that we were using it. So it took a lot of time behind the scenes from my colleagues, who were mainly responsible for the coding and trying to implement as many different conditions as possible. You can imagine that if students are trying to put their inputs of perhaps different impeller speeds, different reactor conditions, there are various unlimited outputs in real life. So trying to get all of that and code for all of that in the Minecraft world was a challenge in itself. So we did have to place limitations, but the innovation there was the use of that particular tool and the application of it in the challenges. So I think what we learned from that was the importance of students being able to computationally model their experiments before going into labs. So something for us to think about in terms of lasting innovation is how we now incorporate that going forward, now that we're in a blended situation.
So the innovation is the tool to enable the students complete their work, right?
Yes, yeah. The use of that tool in particular was innovative on this module.
So for the bioengineering students, they use the tool to enable them to.
Yeah, yes.
Okay, thank you.
That's fine.
That looks like you an adoption of games into the engineering pedagogy. Do you think there's a future for that within engineering education beyond actually what you did?
Sorry, say that beginning part again.
I'm just thinking out loud because I was thinking Minecraft and I thought, oh, so we now are adopting games to quite a significant extent in the curriculum. So I just wanted to hear your views about that process.
Yeah, I think it serves multiple it serves for multiple purposes, because not only because of the age that we live in now, where the use of technology is so important, but also for the way that our students learn now is different to the way that we perhaps learned when we were students. It was very book heavy and library heavy and manual heavy, if you like. But the introduction of gamification allows learning to maybe not feel like a chore. It also allows the flexibility of learning styles to be incorporated as well. So I think that's where we're heading, to be honest. Being able to gamify, contextualize, allow students to really lead in that as well. I think that's where we're heading if we're not there already.
Thank you, Chika. And then I think I'm asking too many questions, but promise this is the last one.
Okay.
I'm quite interested in the adoption of technologies, learning technologies within engineering education. But there is this issue. There are some researchers who think technologies have sort of created what are called echo chambers, like people who are familiar with each other, they tend to stick together, and the technology, to some extent, it helps to make that problem much more difficult, such that things like team working, where you can bring in people from different perspectives, different backgrounds, it breaks down because people tend to stick to their small groups supported by technologies. Or I'm thinking of social media tools like probably WhatsApp for older generation, mostly academics and students have got their own networks. What has been your experiences with that?
I mean, I think that in general, the way perhaps we work in general does, as I said, there are studies that have shown that team cohesion can be supported by cultural similarities, and I think, or rather working pattern similarities. And I think that that's the case whether technology is there or not. Now, with the introduction of technology, I actually have seen that it has the opposite effect to what you've described. So when it comes to students working together and working in teams, technology has actually helped them to work better and to integrate more than the physical environment, because it takes away the need to have to book a room and go to a room and sit together, and all of these physical things that need to be done before you can actually collaborate. With the integration of technology, you're now able to, at a click of a button, be in the same room. And it makes communication a lot easier as well, because it's as simple as what we've had on Microsoft Teams, where the students send each other a message on Teams and arrange a time. And it's a lot quicker. Even students from different time zones can agree on a time and they can meet all together in the time that they've agreed. So I've actually seen the opposite to what you described, but I can understand that in natural ways of working, cohesion might be supported by kind of having your running in your social circles. But we look to break that, we look to disrupt that, so that we can kind of get the best out of having a diverse group and diverse ways of working.
Okay, thank you, Chika. I think looking around whether there are any more questions. Yes, Jay, you can go ahead.
Hi, everyone, and hi, Chika, and thanks very much for that. That was really interesting. I want to ask a question. I hope it's not too tough, really, or challenging. A key issue for inclusivity in education, as we all know, is language. And we're all experiencing a much higher proportion of students whose first language is not English. So could you say something about how the IEP addresses that as an issue? I mean, it overlaps with your answer to the last question, I think, as well. But
yeah, sure. So I think a number of approaches have been taken, but I'll share the ones that I'm kind of more privy to and are at kind of further developed at this moment in time. So so we did see, as you said, the increase in student number also led to the increase in students that don't necessarily have English as a first language. And this was particularly more evident, I should say, in certain departments that had a very high student intake. So a lot of our focus and work kind of started there. We identified the main issues in communication being mainly to do with writing. So something that has been implemented quite successfully in some departments and trialed on the IEP was we've put in, not only that we've increased the staff support with writing and putting in extra writing sessions, there's also collaboration with the academic center of communication with, for example, the Department of Electrical and Electronic Engineering. And what that has meant, that collaboration has meant that we have tailored support from staff that are trained to kind of deal with student issues where English is not their first language. And we also have the collaboration on our side with kind of the knowledge of the content. So that together, we're able to help students further develop their communication right from the first year, first term, and keep those resources available to students as they progress through their degree. So that's one way that we're looking to tackle that perhaps barrier in communication, because the students have the technical knowledge, the students are good students. So language shouldn't be a barrier to them being able to show that. So that's something that we've put in place.
Thank you.
Thank you, Jay. Right, I think we are now coming to the end of our session. Chika, thanks so much for this presentation, for finding the time during such a busy period of the year to put it together and to so eloquently present it as you have done. And to colleagues from UCL and across the world who have joined us today, we thank you for coming. We thank you for contributing, and your presence even is a strong support both to our presenters, our MSc Engineering and Education students and alumni who are now out there in the world doing incredible work to advance engineering education in the various aspects of engineering education. Today with Chika dealing with problems that are bedeviling, as I would say, the engineering education sector within higher education. We've looked at the first talk by Lan Yang, where she she is on a mission to prepare educators in Southeast Asia, in Africa, to become better educators. Yesterday, we had Sama El Sayed talking about creating curriculum, creating learning programs to advance renewable energy solutions. Of course, with climate change and all that, those other things, you actually see that our alumni, our students are really at the forefront of making this a better world. Thank you, everyone. Thank you to the presenters. Thank you to my academic colleagues behind the scenes, colleagues on the MSc Engineering and Education, colleagues within this Center for Engineering Education for providing us with the support to pull off this. Once again, thank you. Have a good day. Have a good night, or whatever.
Thank you, everyone.
And as I always say, let's stay in touch. Contact details are always available. If you want to find anything about the IEP, Chika is there, the IEP team is there. Want to find something about the MSc Engineering and Education, I'm there. Jay is there. The Center for Engineering Education is there. Let's continue these conversations in public and in private. Thank you.